So when we're talking about mid-segments of a triangle, as the video previously showed, okay, every side of a triangle has a midpoint, okay? So D is the midpoint for side AB. E is the midpoint of AC. And F is the midpoint of BC. Okay, so as the previous video mentioned, so if D is the midpoint, that means AD is congruent to BD, and AE is congruent to CE, and BF is congruent to CF. Go back. Okay. So with that in mind, when we connect any of the two midpoints, we get the mid segment. Okay, so based on our color coding here, DE is the mid segment of BC. Okay, the mid segment is always parallel to the side opposite it. So DE is the mid segment of BC, and EF, which we have in black, is the mid segment of AB. And then we have BF, which is the mid segment of AC. Okay, and based on our diagram, DF has a length of 4, EF has a length of 3, and CF has a length of 5. Okay, so with that in mind, we can determine the length of all the remaining sides. Okay, so let's start with, hitting too many buttons here. So let's start with DE. Okay, so DE is the mid-segment of BC. Now, based on the mid-segment theorem, the mid-segment is equal to half the base, or its opposite parallel side. So if I take a look at, we'll do EF, because EF is the mid-segment. EF is 3. So therefore, if EF is 3, that means AB must have a length of 6. And BF has a length of 4, and that is the mid-segment. So the length of the base opposite, or AC, is 8. Now, I saved DE for last because in this case, we just need to remember that if F is the midpoint and FC is 5, that means BF is also 5, giving BC a full or total length of 10, making the mid-segment 5. Okay, so there are two ways that you can approach this. You can say the mid-segment is half the length of the base, or you can say that the base is 2 times the length of the mid-segment. Okay. Now, when we are solving numerically, it seems pretty easy. We're either multiplying by 2 or taking half. Now, we just have to be careful when we're solving algebraically which parts we multiply and which by 2 and what we divide in half. So my other example that I have here is triangle ABC, where BC has a length of 26, and we have our midsegment DE represented by the expression 3x minus 5. Now, so I mentioned that the midsegment is half the base. So I can write this as DE is equal to 1/2 of BC, or I can say that BC is equal to 2 times DE. Okay. Either approach doesn't matter. They'll both give you the same result. So if I was to do DE is equal 1/2 of BC, so that would mean I would have to take half of BC. So 26 divided by 2 gives me 13. So that means that 3x minus 5 equals 13. If I took the other approach, which is BC is equal to 2 times DE, I would say 26 is equal to 2 times 3x minus 5. The only thing to remember here is that you have to distribute the 2 when you go to solve. So what I have is 26 is equal to 6x minus 10. Add 10 to both sides. I get 6x is equal to 36. And when I divide both sides by 6, I get x is equal to 6. Now, if I go solve my initial equation, where I took half of 13, I would add 5 to both sides, giving me 3x is equal to 18. And when I divide by 3, x is equal to 6. So that was pretty simple. The only time you might fall into a problem is if you're given both the midsegment and the base, if they both have an algebraic expression. So let's take a look at that as a possibility. So here we have triangle XYZ, and AB is our midsegment. So following our previous example, I can say that AB is equal to half of XY, or I can say that 2 times AB, my midsegment, is equal to my base XY. Now, when I fill in my algebraic expressions, what I have is x plus 1 equals 1/2 times 5x minus 7, which is totally doable until that's not an issue. The problem is that it could get messy, because when I distribute the half to 5 and 1/2 to 7, I now have 5/2 x minus 7/2. Again, totally doable, but who wants to work with fractions? If you do, great. More power to you. I personally, if the more fractions I have, the more mistakes I tend to make. So I like dealing with my whole numbers. So the other option, of course, is to do 2 times x plus 1 equals 5x minus 7. Now when I distribute the 2, I got all whole numbers. 2x plus 2 equals 5x minus 7. I'm going to subtract 2x from both sides to keep my variable positive, giving me 2 is equal to 3x minus 7. Add 7 to both sides. I get 3x is equal to 9, or x is equal to 3. Okay. This just looks so messy. Okay, so if I am going to add these fractions, oh, what a mess. All right, so let's subtract x from both sides. Okay, now this is technically 1x. So that means I need a common denominator. So what I have to do is I have to do 5 halves minus, and I have to convert 1 into halves. So that's going to be 2 over 2 x minus 7 halves, giving me 3 halves x minus 7 halves. Now I'm going to add 7 halves to both sides. Okay, and of course 1 is the same as 2 over 2. Okay, so far so good. All right, so when I add, what I get is 9 halves is equal to 3 halves x. And of course, to get rid of the denominator, I need to multiply by 2/3. Okay, so obviously these cancel each other out, giving me x. And the 2's cancel, giving me 9 over 3. So x does equal 3. Again, totally solvable, totally works, just more work. And because it's more works, more steps, and I find more steps we have to take, the more mistakes we can make. So again, completely your preference, but I choose whole numbers any day of the week.